In this video, we're going to look at how we differentiate products. Now, a product, we have an example of a product here. You've got a function of x multiplying another function of x, so it is a product. Now, to do this, we're going to call this bit u. We're going to call the first bit u, and we're going to call the second bit v. And the result is this: if you differentiate dy by dx, so if you differentiate, if y is equal to uv, then dy by dx is equal to u dv by dx plus v du by dx. So the way I say it, or the other way you can say it, is y dash, that means y differentiated, is equal to u times v differentiated plus v times u differentiated. Now the way I remember it is I say you write down the first and differentiate the second, and you write down the second and differentiate the first. So u was our first thing, you write it down, then you differentiate the second thing, and then you write down your second thing and you differentiate your first thing. So that's what I have got in my head, but this is the actual formula for it. So if y is equal to u times v, dy by dx is equal to u dv by dx plus v du by dx. And really learn this, it will come in very useful. Okay, I'm going to look at a couple of examples of how we do this. And the hard part is at the end, when you're, quite often it's at the end where you're tidying up, and you'll see that probably when we get on to example 3 in this one, but the first couple should be straightforward enough. Okay, differentiate the following with respect to x. For example 1, I'm going to show the long way of doing this. I'm going to write out my u, which is x squared, my v, which is sine x, and then if I differentiate my du by dx, I will get 2x. Differentiate my v with respect to x, I'm going to get cos x. Then write down my formula. Dy by dx is equal to u dv by dx plus v du by dx, and then fill in the formula. So just sub in what you've got ready. My u was x squared, my dv by dx was cos x, my v was sine x, and my du was 2x. Now all we can do here, we can factorize out an x, leaving you x cos x plus 2 sine x, and that's it. Okay, from example 2, I'm going to do this without using the rule. I'm just going to use what I say, which is write down the first, differentiate the second, write down the second, differentiate the first. So write down the first, you're going to get x cubed. Differentiate the second, you're going to get 2e to the 2x. Then what we're going to do is write down the second, which was e to the 2x, and differentiate the first, you're going to get 3x squared. Now here, what you can do is factorize out, and all you can factorize out here really is going to be an x squared and e to the 2x. So do a square bracket. What you're left with inside then is going to be 2x and 3, and that's it. Okay, and that's that one done. Okay, a wee bit trickier this example, and again, it's the tidying up part of it is tricky. I'm going to use the way I do it, which is say write down the first, which is 3x cubed, and then I'm going to differentiate the second. Now, the differentiating the second isn't straightforward. You've got a function of a function, so differentiate with respect to the bracket, you're going to get 4 times 2x minus 5 to the power of 3. Then differentiate inside the bracket, you're going to get a 2. So that was what I've written down here. This is my u times my dv. Then I'm going to write down my second, which was just 2x minus 5, and that's the power of 4. And then differentiate the first. So differentiate the first, it was 3x cubed. Differentiate that, you're going to get 9x squared. Okay, this is a bit of a mess, so we're just going to tidy this up first of all. So my first part of this part will tidy up to be, just this bit here, will tidy up to be 3 times 4 is 12, times 2 is going to be 24. You've also got an x cubed, and you have a 2x minus 5 cubed, and then you've also got 9x squared times 2x minus 5 to the power of 4. Okay, right, what we've got to do here is a lot of factorizing. So we've got to this point. We then want to see pull out what is common outside a bracket. So we'll start with the easy bit. We've a 24 and we've a 9. What number divides into both 24 and 9? It is going to be 3. So we're going to have a 3 pulled out. So we're just pulling stuff out. We're not worrying what it has to actually multiply with at the minute. So we can pull out a 3. We've also got an x cubed term and we've got an x squared term. So the biggest thing that we can pull outside here is going to be an x squared. And we've also got another term which is 2x minus 5 to the power 3. And also we've got 2x minus 5 to the power 4. So the biggest of these that we can pull out is the 2x minus 5 to the power of 3. Now square bracket, we'll make it a big bracket. Don't know what size it needs to be really, but we'll see. Okay, we've got what do we need to multiply? 3x squared times 2x minus 5 to the power 3. What do you need to multiply this thing by to give you what's above it here? So 3 needs to be multiplied by 8 to get you up to 24. So that's going to be 8 here. Also, the x squared needs to be multiplied by x to get you up to x cubed. So that's just x, so 8x. And we have 2x minus 5 cubed. We've already got 2x minus 5 cubed, so we don't need to multiply anything else by that, so that's fine. Okay, the next term, what do we need to multiply the 3 by to give you 9? So that's going to be a 3. We've got our x squared term, and it's x squared, so we don't need to multiply anything here, it's fine. But you have 2x minus 5 cubed, and you need to get up to 2x minus 5 to the power 4. So that needs to be multiplied by a 2x minus 5, and that should be us. Okay, tidy up, we'll write our 3x squared times 2x minus 5 cubed, and inside this big square bracket, we're going to multiply out and tidy up. So we'll just do that in 2 steps. You're going to have 8x plus 6x minus 15. And then we'll tidy that last thing up again. That's going to be 3x squared. That's going to be 2x minus 5 cubed. 8x plus 6x is going to be 14x. And then minus 15. Just check that there's nothing else that factorize outside out of this bracket, and there's not. So that is as good as we can go, and that's us done. Okay, example 4, we've got a product again. We've y is equal to e to the x squared times sine of x squared. So I'm just going to use my method, which is write down the first and differentiate the second. So if I differentiate the second, it's going to be cos of x squared. Differentiate the angle, you're going to get 2x. And then this time we're going to write down the second, and we're going to differentiate the first. It's going to be e to the x squared, and differentiate the x squared, you're going to get 2x. Okay, now we're just going to factorize this and see what we can actually factorize outside here. So you have 2x is multiplying both terms, you have e to the x squared is multiplying both terms, so we can pull it outside. So you're going to have 2x times e to the x squared, and it's multiplying then cos of x squared plus sine of x squared. Okay, and that is as good as we can go on this particular example. Okay, one more fairly tricky example here. Again, it's a product. We're going to differentiate. Now the first thing I'm going to do here before I differentiate actually is write this in index form. So that's going to be 2x minus 1 to the power of a half. So it's y is equal to x squared upon brackets 2x minus 1 to the power of a half. So we differentiate, write down your first, then differentiate your second. I'll use a square bracket. So that's a half times 2x minus 1. And the power of your bracket goes down by 1, so it goes down to minus a half. And differentiate inside your bracket, you will get 2. Okay, we'll be doing a bit of tidying up here. Don't worry. Next thing, write down your second thing. You'll have 2x minus 1. And then differentiate your first. You're going to have just 2x. Then tidy that up before we do anything else. That's just going to be x squared times 2x minus 1 to the power of minus a half, and then plus 2x times 2x minus 1 to the power of a half. Okay, we want to then factorize out what's common. You've got an x squared term and you've got a 2x term, so you can pull out an x from it. You also have got 2x minus 1, this bracket and this bracket, they're the same, but they've different powers. So when you factorize out, you pull out the smallest of each, so we want to pull out this one here. So out comes 2x minus 1 to the power of minus a half, and then we'll do our square bracket and see what has to go inside. Okay, x has to get up to x squared, so you need to multiply by x, and you have 2x minus 1 to the power of minus a half. So 2x minus 1 to the power of minus a half is already in this one, so you don't need to multiply anything else. Over here, x needs to go to 2x, so you need to multiply by 2. And 2x minus 1 to the minus a half needs to get up to 2x minus 1 to the power of a half. So you need to multiply it by 2x minus 1 to the power of 1. I've written the 1 in here, but you don't really need it, but just that you can see why it is. So if you did 2x minus 1 to the power of minus a half times 2x minus 1 to the power of 1, it would take you up to 2x minus 1 to the power of positive 1/2. All we've got to do then is tidy up inside the square bracket, so it's x upon 2x minus 1 to the power of minus a half, and inside this square bracket is going to be x plus another 4x, which is going to be 5x, and then 2 times minus 1, which is going to be minus 2, and that's it. I'm just going to write that again. Just don't like having the square brackets. That's going to be 2x minus 1 to the power of minus a half times 5x minus 2. Okay, this next example looks horrendous. It says, if y is equal to e to the x ln of x, prove that x times d2y by dx squared is equal to 2x minus 1 upon dy by dx plus 1 minus x upon y. Okay, to do this, what we're going to have to do is find, first of all, your dy by dx, and then once you've found it, you can find your d2y by dx squared, and then see if the left-hand side, so x times whatever you got for your dy by dx, would work out to be the right-hand side, which is 2x minus 1 upon dy by dx plus 1 minus x upon y. So we have a fair bit of work to do. Okay, first thing I'm going to do is I'm going to get started doing my dy by dx. So my y was equal to e to the x ln x. So write down your first term, differentiate the second term, then write down your second term, just put in a bracket, differentiate your first term, you'll get e to the x. And again, it is so valuable here if you tidy this up and factorize out. So this really is the same as e to the x upon 1 over x plus ln of x. Now 1 over x is difficult to differentiate in its current form, so I'm just going to write it as x to the minus 1, and then I've got my plus ln of x. I've now got my dy by dx as a function. So this is a u, this is my u term, and this is my v term. So when I'm going on to find my d2y by dx squared, it's just, again, it's a product, I should say. This is my u and my v in my product. So we'll go on and we'll differentiate d2y by dx squared. And it's not difficult, this, it is just, there's a lot to it. So I'm writing down my first term first of all, which is e to the x, and I'm differentiating my second. So bring my power down, and then reduce the power by 1. So that was me, that's how I've differentiated my x to the minus 1. Then I've also got to differentiate my ln of x, which is 1 over x. Then I'm going to write down my second term, and I'm going to differentiate my first, differentiate e of x, that's easy, it's just e of x. So again, we're going to factorize. Take e to the x outside a bracket and see what you're left with. You're going to have, minus 1 over e upon minus 1 over x squared plus, where are we here? Sorry, where are we? We're going to have two lots of 1 over x, and then you're also going to have your ln of x. Let me just check that and see if that's right. Minus 1 times x to the minus 2. Yep, that's minus 1 over x squared. And you have 1 over x, and x to the minus 1 is another 1 over x. 1 over x plus 1 over x is 2 over x. And then you've got ln x, which is here. Okay, I want to just investigate what x times my d2y. So I've got my dy by dx, I've got my y, and I've got my d2y by dx squared. So I want to investigate what my left-hand side would look like. So I'm going to look at x times d2y by dx squared. Now that's in this form, it's going to be fairly easy. So we'll just say, therefore, x times d2y by dx squared equals e to the x upon, and if you multiply x into this bracket, you're just going to get minus 1 over x plus 2 plus x, then x. So now what I'm left to do is check that this thing is going to be the same as if you work out the right hand side. So we'll do that up here just and see. Okay, and we'll just say 2x minus 1 times dy by dx plus 1 minus xy is equal to, so that's going to be 2x minus 1 times my dy by dx. Where on earth is my dy by dx? It was e to the x times, and I'll write that as 1 over x. It'll be easier to write it in that form. 1 over x plus ln of x plus 1 minus x times my y, and y was equal to e to the x ln x. Okay, so it's not pretty, but we'll just have to go through it. Right, first of all I'm doing 2x times e to the x times 1 over x. So that's just going to be 2 e to the x. Then I'm going to do 2x times, 2x times e to the x times ln x, which is just going to be 2x e to the x ln x. Then I've got minus 1 times e to the x times the 1 over x. So that's going to be minus e to the x times 1 over x. And then I've got minus 1 times e to the x times ln x. So that's minus e to the x ln x. And then my last thing, I'm just multiplying this times this. So 1, so I'll just do that on to the next line. That's me plus, I've got 1 times e to the x ln x, and then minus x times e to the x ln x. What a mess, but we'll just tidy up and see what happens. First thing I notice, I've got minus e to the x ln x and plus e to the x ln x. They will go. I've also got 2x e to the x ln x, and I've got a minus x e to the x ln x. So one of those will cancel out. So what I'm left with, I will be tidying this up again, don't worry. I'll have 2x plus x. Sorry, that should have been an e to the x. I'll tidy it up properly in the notes. That's going to be 2e to the x plus x e to the x ln x. And then I'm going to have my minus e to the x times 1 over x. Okay, doesn't really look like what I have, but I just say take out an e to the x, and I've got, first of all, I've got my minus 1 over x. I've also got 2, and I've got x, then x. So I've got there eventually, so I've shown that x d2y by dx squared is equal to 2x minus 1 upon dy by dx plus 1 minus x y. I will just write that in at the end to show that I have understood all of that. So just say, therefore, x times d2y by dx squared equals 2x minus 1 dy by dx plus 1 minus x upon y. I just write as required, and that is it. Okay, folks, that was a difficult example. Be a lot of marks for an example like that in an exam. You're now ready to do exercise topic 6, exercise 6, questions 1.